so just clear your minds. I knew this was gonna happen, it happens every time we do this with the sequences chapter. There's so much information. We're going back to this. Forget a second. Now, I'm gonna use the rest of my time to, I'm gonna actually start with part one on the review I gave you guys yesterday. I gave the answers also, I'm pretty sure. I'm gonna work as many of these as I can, and then I will let you know as I go through. I don't see anything wrong with it. Any particular part that you will definitely have on the test. Okay, so I'll say, make sure you know this one as we go through this, okay? As we go through these parts. Guys, we'll get this much done, as much done as I can. Beautiful. We'll get done. And then tomorrow, probably finish this up. If I don't finish it up today, I doubt if I finish it up today. Pick back up and finish this up tomorrow, okay? And then, let's see, was there another handout I gave you guys, like topics? Topics for the final? I think I gave you a handout last week for that. Is that true? And I'm gonna start looking at that with you. Now, what I would love to see is, and I think in this class, more than one student will do this. I'd like to see a perfect score on the final exam. I mean, not one mistake. I'm gonna throw that challenge out there. You say, Professor, is there some extra credit on the final? There will be. There'll be some extra credit at the end. No, I want a student who does that final without the help of the extra credit, and they have a perfect score. I'd love to see that. If I see it, I will notify you. I'd like to notify you, congratulate you. Arena, we may have to go out and buy some chocolates. But I'm looking for a student, or more than one student, especially in this class, to get a perfect on this. Okay, guys, let's jump into it. Jonathan was asking, says, Professor, I went through part one of these on my own, and I see what you're doing. You're doing a mix of stuff here. Part one says, evaluate. Yes, I tried to, example, make a mix of things here. First one was written merely as this: cosine sine of pi. And the way we're going to look at this is sine of pi from the unit circle, guys, is 0. And you're trying to take the cosine of that, and then on the unit circle at 0, the cosine is 1. And there you go. And I did provide the answers. B, this is the one he was asking about. Log base 2 of radical 2 over 2. Now, this is the way I would translate it. It's up to you how you want to translate it, though, guys. I've seen some students do this. They'll say, rewrite this as log base 2 of, and then they do something here. They modify that a little bit. They rewrite that radical 2 as 2 raised to the 1/2 being divided by 2. Then they go a little further, knock that off. Then they're saying, okay, let's rewrite this as log base 2 of, and then from elementary algebra, I can subtract the exponents. That's understood to be an exponent of 1. So for this case, a raised to minus the n, subtract the exponents. That would end up as 2 raised to the 1/2, subtract 1. Which now gives me log base 2 of 2 raised to the negative 1/2. If you approach it like that, then you probably say, well, Professor, can I go further? Of course you can. You could, through a property of logs, take this out front, power property, and rewrite this now like this. Now, guys, this is one approach. Power property, lift that exponent out front, and this log of 2 base 2, we all know, is merely 1. 2 raised to 1 is 2. I got negative 1/2 times that, and Jonathan, that's one way to see this answer. That's one way to do it. I've seen this happen. Some students will recognize this as a quotient at the very beginning, and say apply the quotient property. It's a log, and the quotient property says I could rewrite it as log base 2 of radical 2 subtract log base 2 of 2, using the quotient property for logs. And we know this is 2 raised to the 1/2, if that would help. Move the 1/2 out front, power property. If you wish to use this method, subtract log base 2 of 2. And Jonathan, you're going to end up with that much, of course, is 1. So you're going to end up really 1/2 there. This is 1. You got 1/2 subtract 1, and there's another way to get the answer. So lots of ways to think about this. Final answer though is a negative 1/2 at part B. Part C, not too bad here, from what I see here. Sine of 5 pi over 12. Hey guys, I need some help here. This is all of you. This is more in line with exam 4 that you guys just recently had. Anyone tell me a way to express this 5 pi over 12? Can you find the value? What do you think?
Sine alpha plus b.
Do it again.
Sine alpha plus beta. We can
Oh, sine A plus B?
or minus.
Okay, hang on. Ema. So you're trying to come up with maybe the sum of two angles, let's call them A and B, that would give you 5 pi over 12, then apply the sine A plus B formula. Is that true? Is that what you're thinking? Okay. Which would be, if it works, what is that? Sine A cosine B plus cosine A sine B. Make sure I have all that up down correct, you guys. Is that the sine A plus B formula? I think. I hope. Is it? Now, Nima, what do you have in mind for 5 pi over 12? Because you were saying please write it as an A plus B so I could apply the formula. What did you have in mind to do? That's 5 pi over 12.
Pi over 4 plus pi over 6.
Okay, hang on. 5 over 4 plus 5 over 6. And Jonathan, if I combine those two right now with a common denominator of 12, I just multiply this one by 3, of course, this one by 2, 3 plus 2 is 5. That would give me 5 pi over 12, and that's what I need. Is that true? Okay, I can use that. Other choices out there? I'm sure there's other choices. But since he's giving me that choice, I'm going to apply the red formula and have sine of pi over 4 cosine pi over 6 plus cosine pi over 4 sine pi over 6. All this should bring back memories. If all that's copied down correctly. Guys, here goes from the unit circle. We know this is radical 2 over 2, definitely. Cosine of pi over 6, radical 3 over 2. Cosine of pi over 4, radical 2 over 2. And thank goodness that's a 1/2 on the end. Final answer, radical 6 plus radical 2 over 4. For sine of 5 pi over 12. Now, before I leave it, I think that's the answer. I think more than likely that's what I had to put the answer on the answer sheet for this one. Can anyone tell me though, a student may approach this differently? Can anyone tell me, well, let's see if we can. Yeah, we could. Can anyone tell me, I'm not gonna do it completely, but can anyone tell me another way to approach this and not use the A plus B? Nima, I would use the A plus B like you did. Does anyone see another way that you could have approached this?
120 minus 45.
120 subtract how much?
45.
120 subtract 45, okay. And 5 pi over 12 is 75. 120 subtract 45. Okay, I'll take that. And then you'd be using an A minus B formula, if that were true. I'm thinking about something else. I've had clever students. If it's open, I don't say use the A plus B formula or A minus B formula. It's open. Can someone give me another option? we get?
Half angle.
Half angle. We write this as sine of 1/2 of, look at this. 5 pi over what? 6. That's 5 pi over 12. And then apply the half angle formula. Now, when you get your answer, it may not look anything like this. But if you actually should calculate it at the same values, if you look differently, you can do that. I think most students will probably use an A plus B if I leave it open. Okay? That's letter C. Letter D is cosecant of inverse tan of 5. You guys just finished up exam 4, and you're probably thinking, oh no, I thought we were finished with all this inverses. Oh, professor, right back in inverses again. Now, if I leave it open, I think on the exam I asked you to use identities. On one of the problems, you guys had to show me identities. But just leave it open though, guys, you can use triangles or identities. Can anyone give me an approach here? Cosecant of inverse tan of 5. Now I will remind you, this is one that has restrictions, or a restriction. How's that? Quadrant 1, quadrant 4. I want cosecant. Does anyone want to do it through identities? Can you come up with an identity that may finally connect all this? Or did you want to jump right into a triangle? It's up to you. Let's try identities if we can first. Anyone have an identity in mind to get there? Oscar.
1 plus cotangent squared.
Whoa, I like that. 1 plus cotangent squared is equal to cosecant squared?
Yeah.
Love it. But I think in math 7, by the way, all this is in math 7. Guys, you don't have to worry about not it being there. This is in math 7. And a lot of the instructors will require you to use identities. 1 plus cotangent squared, Oscar, love it, love it, love it. Now, what are you going to do from there?
So tan is equal to 10 theta is equal to 5.
Hang on, so we know tan of theta is equal to 5. That's what that said. And therefore,
Cotangent equals 1.
look at that. See all those relationships? Now I'm assuming, Oscar's correct me if I'm wrong, you're going to go down to this, I guess, now make a replacement. Is that true?
Yeah.
And write this as 1 plus and cotangent squared, that 1/5, I guess, squared, to be put in. Okay, guys, gotta clean this up. There we go. That's gonna be 1 plus 1 over 25 on this. Common denominator, looks like it's 26 over 25. Strange, but that's it. And this is, I'm looking for a cosecant to a square root. That's what looks strange too. Radical 26 over 5. After I do the square root. Now, are we in quadrant 1? Should I accept it to be a positive? Because after I did the square root, actually at one point it's plus or minus. Should it be positive in this case? And how do you tell?
Quadrant 1.
Yeah, are we in quadrant 1 if we look at the information given to us there? So should it be positive for the final answer? Did someone check that answer on the answers I passed out? Did I leave it just like that? Radical 26 over 5?
I think so.
I left it like that. Yeah.
Can you do the math on that? Like, it's kind of strange to have a radical 3 over 2 underneath the radical for the sine.
Which one you looking at?
1/2 of 5 pi over 6. Bottom right, the one you
Oh,
see.
this down here.
The math on it, I don't know.
Oh, the math's gonna be crazy because you gotta use a half angle formula.
Yeah, so I know you were like 1 plus the square root of 3 over 2 over 2, and then I'm not sure how.
Let me come back to that. I'll come back to it. I'll come back to it. Okay? Guys, is this one okay? Are we okay with this one? Okay. Before I leave it, Michael, just in case, some students like this, they'll say, Professor, I love triangles. So let me go back and just do a quick translation. Someone said I'm in quadrant 1, guys. Inverse tan 5, Oscar says it means this. There's an angle out there whose tan is 5. And we're going to be in quadrant 1. You place that angle in quadrant 1, theta. Drop a perpendicular and express that tan is 5. Tan is opposite over adjacent. That's chapter 7. Or y over x. So guys, could I place a 5 here and a 1 here to express y over x, tangent is 5. If I do, then use Pythagorean theorem, you will end up with square root 26. Let's see if I do this now. Of course, we're accustomed to a unit circle, so we have in class been doing this to modify, divide all this by square root 26. And then when they're asking for cosecant, which is 1 over y, and the y in this case is this number here on the triangle. So 1 over that, and just flip it over and give you this. So you could do it through a triangle also. Okay? Jonathan, let me come back to that just a little later, okay?
All right.
Okay, guys, let me see what else is involved here. Some of these ones are involved. And the last one there looks like, not the last one, next one. Inverse tan of this. Negative radical 3 over 3. By the way, when I graded the exam for it, just brought it to memory, many of my students, and of course you could not use that unit circle. I didn't pass out a copy of the unit circle. Many of my students drew the unit circle on the back. And they wrote me a little note, Professor, the unit circle's on the back. Some students did not, they just jumped into it and did the work, but some students said, no, I prefer to look at that unit circle. I think I had that unit circle filled correctly. Every angle was marked correctly, which took a little time. Yeah, it did. So I hope you guys know that unit circle well enough now where maybe, unless it's really necessary, you don't have to really draw it to reflect back to it. Guys, this one says there's an angle out there whose tangent, this is translation, whose tan is this. And since I see an inverse, again, there's a restriction. It'll be located here. Quadrant 1, quadrant 4. Okay. Looks like I'm being quadrant 4 on this one. Tan is negative down in quadrant 4, not quadrant 1. Now, I hope from the unit circle, when I place y over x, I can find this angle. Guys, does anyone have a possibility from the unit circle? An angle that if I place the y over the x, I get that radical 3 over 3.
Negative pi over 6.
Here it is. Beautiful. Now, Rebecca, 5 or 6 itself, I think, had these coordinates. That's true, guys? And she says, Professor, if you place y over x, 1/2 over the x, radical 3 over 2, you will definitely, when you clean it up and rationalize, she said you will definitely get radical 3 over 3. I agree with her 100%. And she says you got to place a prefix of a negative, because it should be done in quadrant 4. Absolutely. Thank you. Now, and the last one of that group, ln, natural log, sine of pi over 2. Not too bad. Sine of pi over 2, we all know is 1. That's the y coordinate at 1. Now, what's the ln of 1? 0. You guys who may have forgotten, the answer is 0. The reason why is e raised to the 0 is 1. What it translates into. Okay. Now, here's what I've been looking forward to. It's been too much time since we've seen a piecewise function. Now, if I want to be really scary, on the final exam, I could place a piecewise function, which I'm not gonna do with this, so that I could. And one piece could have a logarithm in it. A second piece could have a trig function in it. I could, because the course is finished. So I could include in that piecewise function, maybe a log one, trig functions one, another piece. This one you have, see on your handout is more in line with what you guys saw when I first, I think, did piecewise functions. I will sort of stick with that. I'm not gonna go crazy on you. I'm gonna put a sine or a cosine in one of those pieces. So guys, this one, if I graph it correctly, has three pieces. And it's given as this. First piece, nearly negative x if, constraint here, if x is less than or equal to 0. Now, since we haven't seen this in a long time, I'm gonna be careful with these different colors here. Next one's 9 subtract x squared if, and here, if 0, yes, is less than x, less than or equal to 3. The last one, move here, x subtract 3 if, and this one says if x is greater than 3. I think I have the final exam ready for you already. It's here. I've already constructed it. I think, if I'm not mistaken, either, and you better mark this so you know, there is a piecewise function, I think on page 1 of the 18 pages. See, on the first page, there's a piecewise function to be done. It's not 8 pages, my goodness, maybe 5 at the most. Okay. Guys, so I need you to take a close look at this on page 1, piecewise function to open up the final. Here we go. Rough sketch here. Now, many of us, at this point, we say, Professor, I don't know what the green is going to graph into. It's going to graph into a piece of a straight line. I think what I did when I introduced this to you guys, just to play it safe, I think we created a little table on the side here. I don't see anything wrong with this. And we tried some numbers. Like on the side there for the green, it says anything less than or equal to 0. I'm going to start with 0. Now we'll try something less than 0. Let's try -1. Just a couple points. So I put a 0 back here, it becomes -0, which is 0. If I replace x by -1, negative -1 is going to turn into a +1. That should be enough. 2 points determine the line. That should be enough to plot to see what's going on. So guys, you got 0, 0 for the green, which is supposed to be included, and out -1, up 1. Right there. And then I need to connect and see if you guys will agree. Does it look something like that? Is that piece number 1? Done. Piece number 2 in the red, many students would recognize at this point, since the course is over, this should graph into a what? Piece of a parabola. Now if you want to try a table with the numbers given, I don't see anything wrong with that. I got a 0 here, looking at the 0 first, put a 0 back here, 9 subtract 0 squared, it's going to give me a 9. I'm going to try maybe a 1, something in between. 9 subtract 1 squared would be an 8. And finally, let's reach 3 here, guys, and see if that might be enough. The 3 there, 9 subtract 3 squared, it's going to give me 9 subtract 9 is 0. That should be plenty enough to see the shape of this parabola. Okay, first point 0, 9, and one thing I gotta be cautious about, 0 up 9, the way it looks, should not be included. I don't see an equals mark, so it should be open. The other points definitely will be included on this one, so out 1, up 8. Yeah, I'm gonna say it falls right in there. 3, 0, I'll be out here. the scale here, and looks like connected, I'm gonna have a piece of a parabola doing something like that. You guys agree? Second piece. Third piece should be a piece of a straight line in the blue. I am gonna start out with 3. Put a 3 in there, 3 subtract 3 gives me a 0. It says anything greater than 3 also, we'll try 4. 4 subtract 3 gives me a 1. 2 points should be enough to plot. When I go to 3, 0, which is right here, on the blue, it was not supposed to be included, but was it darkened in from the previous? So I cannot reopen it. I've got to leave it closed. And then out 4, up 1, I plot it somewhere in here, connect, and there's piece number 3. Let me step back and look at it and see if you guys agree with that. Is that the way the piecewise function looks? You put all the pieces together. The truth? It's been a long time since we've seen one of these. Now the slide there has some interesting questions about this. But first, guys, before I jump into the interesting questions, can anyone tell me the domain, the extent from left to right on this graph? Can I say it's negative infinity through positive infinity? Or should I be cautious and leave something out? Or from left to right, is it all real numbers? It's all real numbers. I know what I'm looking at right here. That point right there I see is open. I know that would concern me as a student. The coordinates here, 0, 9, and I'm looking for domain. Domain's the x. I see a 0, but is 0 being picked up down here on the green? So it is negative infinity through positive infinity. A range, I think the range is easier seen. Guys, the up and down looks like it might be, help me out, is that also, well, not also, but is it bracket 0 through infinity for the range? Now, Adrian, I know your little group will be working with you to get ready for that final. So, on the side here, I had a few things to ask. Hang on just a second. Find f at, for this piecewise function, f of at a -4. Now what you guys are accustomed to, if I ask for f of a -4, you go to your function and plug in -4. But that does not mean you go to the green, the red, and the blue and replace all those x's by -4 and get 3 answers. No, you have to see which of those 3 does -4 fall. And guys, -4 would fall here since that x is less than 0. So I'm using only piece number 1 to get the answer. This is where -4 falls. If I use piece number 1, the green, it says -4, piece 1, turns into 4, and that's the answer. Finished. Next, I was asking on the side here, f of radical 2. Do not go to all 3 pieces. You gotta find where radical 2 fits. Radical 2 is 1 point something. Looks like it fits in the red. Caught here. So we use the red to get the answer, the value. 9 subtract radical 2 squared. Guys, if I do the math correctly, I think it's a 7. And you'd be done. Next, f of pi. And pi is roughly 3.14. And I guess that would be right here in the blue. So I'm using only the blue piece. It says x subtract 3. Just leave it pi subtract 3 and I'm happy for an answer. And it looks like I threw in one more. I sure did. F of sine of 5 pi over 6. To take you back to the unit circle. Guys, sine of 5 pi over 6 is it 1/2? So it comes down to find f of 1/2. Let's see where 1/2 fits. Guys, does 1/2 fit here? The red piece. It's caught between 0 and 3, 1/2. Use the red piece. 9 subtract x squared would be 9 subtract, in this case, 1/2 squared. that was 9 subtract 1/4. And if my math is correct here, what is that, 35 over 4? Strange looking answer. Was that the answer on the handout?
I think I read it as 5 pi over 3.
Oh, was it 5 over 3? Not 6? Did I write down wrong? Should have been 3 rather than 6? Okay, we got 6 also though. Okay, here we go. Let's do 3. And the sine of 5 pi over 3 is? That's the sine of 5 pi over 3, because that might be in degrees. I'm looking at what, 300 degrees? Am I down quadrant 4? So the sign down there should be negative. And what is it? Is it radical 3 over 2? Which gets more interesting. Oh, I put a 5 pi over 6 there. It should have been 5 pi over 3, you guys are telling me. Now this will change. We got 5 pi over 6 though, just for a benefit. Now this one looks more interesting. Let's see why now I placed it on there. A little bit more interesting than the other. Here we go. Now if I go to my piecewise function to see where this fits, I guess it's got to fit here. It's a negative. Therefore, if I go to the green piece, the answer should be negative radical 3 over 2. And that's going to turn into a positive radical 3 over 2. And that's the answer. It's on your handout. Now, can we do some of those? A piecewise function and some of those. Should I keep it to 3, maybe 3 pieces, or should I extend it to maybe 5 pieces? Oh, 8. Belongs says 10 pieces. Just go ahead and give 10 pieces, professor, and have among those 10 pieces a log, and then another one's a trig function. Make it interesting. That's what it'll take the whole page of the 10-page test. Why not? Okay. So guys, that's a good start. I gotta watch my time here. Now, let me do this. We're gonna jump around. We're gonna finally eventually get to all this stuff. Here's another one we haven't done in a while. Rebecca, she was asking, what is yesterday, to the professor on the rational function. This is for a reason. She said, are we going to be responsible for an oblique asymptote? On the exam, when you had an exam with me on the rational functions, I think it was a horizontal. If I'm not mistaken, there was a crossover point on that particular one on that test. So I have not done an oblique yet. I did it for a reason. I saved it. Rebecca, I'm glad you brought that up. Here we go. On part 5, guys, hold on, part 5. Looks like this one will have a horizontal. Is that true? But Rebecca, just in case, I will show you one tomorrow with the oblique. Just in case. Who knows, by Friday when you open the test, you'll say, oh my goodness, thank goodness, professor, you gave me one with horizontal. Not an oblique. But you may open the test and say, oops, it's an oblique. So I'm going to do that oblique tomorrow. Now the way we're going to close down today is, I saw one on here besides that one, was we haven't done one of these in a while. Part 4, where it says find all the zeros. Now you guys want to help me on this. Find all the zeros of a polynomial function. Jeez. Here we go. Now, are you guys appreciating all this being worked out?
Yes.
Yeah. Some instructors just give it to you, you're on your own. That's it. This one, though, is probably very close to closing down class today, is this one. The polynomial function is p of x. And it is, and whoever attempted this, may help us.